but then about age 11, they forced me to go to school. You know, the law says you've got to go to school. I hated the idea. I'd rather educate myself, but I had to go to school, and some of the teachers there were really quite useful, and some of the boys were all right too. But I hated it really, and I wanted out. And just before I got to my 16th birthday, I left and went to live with my lover in London, an older woman, and had a rare old time. And I started running my own businesses in London and thinking, I can't be bothered with all this maths and technology stuff. But it sort of pricked my conscience, but I thought maybe I should get a proper technical education. So I signed up for a polytechnic in London that was doing a 4-year honours degree in electrical engineering. And after a few months, I realized I don't need to go into the classes. I know all this stuff already. And I had a job doing 12-hour nights at a petrol station. Now, not many chaps drive their Bentley Mulsanne turbo into your petrol station at 2 o'clock in the morning. It does happen, but not very often. The petrol station was open for company political reasons. And so I virtually had nothing to do and a tax-free income. And so I studied these books. I also took the government's penny because in those days, the cost of that education was negative. They not only paid all your fees, but they also gave you about the equivalent of today, $15,000 a year in expenses to cover your living expenses. And so it was fine. And I got a first-class honours degree out of it. And after that, instead of carrying on very sensibly with my businesses and, you know, just trade in London, I thought, I better make use of this degree. And I got headhunted by the nuclear power company, who were building Britain's advanced gas cooled reactors. And it was fascinating, you know, because my colleagues were all doctors of theoretical physics, and they understood all this stuff about, you know, protons and neutrons and nucleons and nuclear physics and energy. And I was able to tap them for the bits that I hadn't picked up from doing my electrical work. And after a couple of years of that, I think it was about 3 years, I realized I wasn't really making enough money at this nuclear power station game. And so I got a job with a very nice young chap out in the Middle East who'd been given the task of supervising the water and electricity department in his emirate. And he and I got on like a house on fire. And my job was being knowledgeable of the world and of business and money and balance sheets and things like that, and profit and loss and cash flow and engineering. I was useful to him because I could supervise contracts for him, multi-billion-dollar contracts. I could supervise them and enforce them, you know, make sure that my employer or my client got good value out of those contracts. And that was immensely profitable. I was paid 10 times more than anybody working in the UK was paid to do that. I was paid 10 times more. And I didn't pay any tax at all. You didn't have to pay any tax out there. So it was wonderful. And it went on for nearly 10 years. But then I thought, I've had enough of this. I don't even need their money anymore. And I'd like to go back home, please. So I came back to England. And in 1983, I went to the Cranfield School of Management to do a Master of Business Administration, which was another waste of time for 2 reasons. One, because there's no point in getting an MBA unless you're a chosen child of some corporation that wants to move you up the ladder. And for the second reason, that I'd already studied all those books about accountancy and business management and marketing and things. So I didn't really need to go in. I mean, I did enjoy the social interaction, but it was really just that. And so I left and started my own company making electronic instruments for the energy industry. And in 2007, I said to myself, you know what, I don't want to do this anymore. I don't need the money. I'm not going to do this. I'm going to go back to that childhood stuff and sort this out. So this came up in the previous talk. There's a dirty secret in the astrophysics trade, and that is that they don't know how any star in the universe formed. Now, that's a rather serious problem, I would have thought, because if you don't understand the mass compaction mechanics of a single star, and the universe is full of pretty well nothing but stars and empty space, then you've got a problem. And if you don't think that's a problem, then you've got a real problem. So in 2013, I published a book called Mass Compaction Mechanics, which explains the tidal and gravitational forces that cause the condensation of a star from a disk of hypercold dark matter. when it's interfered with by a nebula cloud, which is much warmer than the dark star is at a temperature of, I think, about 10 to the minus 20 or to 10 to the minus 40 degrees Kelvin, something like that. You can't see it. It's completely transparent. It's not transparent. It's completely reflective. It's like a mirror, superconductive. And that gets destabilized when a nebula cloud of debris from another cloud formation basically passes across its wake and excites it into collapse. And I published this book. I did put a technical appendix in the back explaining why you could have dark matter at temperatures so low, and explaining basically the physics of the universe. But the only astrophysicist who read this just said, "Oh, sorry, old boy Ben, you just can't have such cold dark matter. It doesn't work. Don't you know the cosmic microwave background is 2.735 degrees Kelvin, so there can't be matter that cold in the universe." And I just thought, I'm out of it. I'm not going to try and help astrophysicists anymore. And in 2015, I thought, I know what, let's tackle the quantum physics of this, because there's something that they don't know that they ought to know, that I taught myself when I was 9 years old, basically. And that is that we don't know what time is. We know what space is, because in 1980, fantastic, alhamdulillah, they announced that the units of space are the light time of flight, 1/c seconds, 3.335 nanoseconds. And it doesn't matter what the gravitational field is. Einstein's field equations show that it's always going to be, 3.335 nanoseconds. But if a meter is 1/c seconds, then the speed of light becomes a nonsense, because it's c times 1/c seconds per second. Now the seconds cancel out and the c's cancel out, and you end up with 1. And that must be wrong, because space and time are not the same thing. Space and time are different things, and space definitely is time. So what is time? It's something like space, but it's different. Yeah, it's different in a subtle way. And the subtle difference between space and time is that time is actually the imaginary historic depth in I seconds. Yeah, and that explains your instant quantum action at a distance. And it also leads to, I will now share my screen if I can. Can I do that? Yeah, there we go, share. So if you go on my website, which is, I just found out this morning, by the way, if you just type in GNQR, no commas, use capitals if you like, good old Google or whatever they are, they pick it up straight away. They don't even give you a list of things that this could be to decide what you want. It just goes straight to my website. That might not work for you. The actual website is lowercase, of course, gnqr.co.uk. What this diagram is showing us is what the result of my work shows. And this membrane here is rather similar to the membrane which the previous speaker referred to. This is formed by Einstein's general theory, integration of Einstein's field equations. And this is your proton here. You mentioned that. That's down there. Now, why am I the only one who's noticed that the proton RMS charge radius is about 1,000 times smaller than the gamma wavelength? Well, this explains exactly why. The proton charge phase exists at a massively compressed scale of space and time, and the strong nuclear force is gravitational. Also, the weak nuclear force is gravitational. Even electrochemical binding energy is gravitational. What this membrane shows is a 2D presentation of the 3D static or standing event horizon of time now. This event horizon just stands still for all time. It's just static. History moves back off into the past, and we can get effects coming from the past, but everything in the universe lies above this event horizon of time now. And it's rather peculiar, but it could equally be referred to as the escape horizon of time zero. And here's your non-existent graviton down here. The cosmological depth of the proton is shown to be infinite. to see this merely apply general relativity, as you now know it, to a graviton of 0 apparent radius. And Einstein gave us this equation as part of special relativity. And that equation is nonsense, but it's correct nonsense, because it's not wrong in itself, of course, but it is only that the unit stated, mass, what the heck's mass, and c, what the hell's c? Well, c is actually 1 over minus 1i, and c squared is e to the I pi, which just means -1, basically. And me here is the quantum energy that is trapped in the gravitational hole. And so we get the same equation, but it just looks a bit different. And what's really exciting about this, or what I found exciting about it, is, can I stop sharing my screen now and go back to me, just me looking at it? I don't know how I can do that. So what do I do?
Click on screen button once again so that you'll be able. Yeah, perfect. No. So I guess Dr. Van has left. Just give us a second. We'll just see. Let's just wait for Dr. Ben to join the session so that he'll be able to continue the presentation. Yeah, Dr. Ben has arrived.
Hello, can you hear me?
Yeah, I can hear you.
Sorry about that.
Please
I
continue.
accidentally shut the GoToMeeting system down because I was trying to get rid of my own graphic, which I didn't need anymore. So the thing to do if you want to study this theory, which basically is telling you that the the arithmetic that we were taught as children is nonsense, basically. You need this rotational, Gaussian and Euler-esque rotational arithmetic, and you need to know what I means, what the square root of -1 means. And I've already explained it. You know, 1 is going in that direction, and e to the I pi, we go into the other direction, you know, minus, and halfway between you've got this. And it's all explained in diagrams on my website. But until you've got your head around that, there's no chance. There's just one other point I'd like to make, quantum entanglement. When we see a quanta, which is well known by quantum physicists, when we observe a quanta, which could be from a distant galaxy, that quanta is still entangled with the historic emitter, which was some kind of atom in a galaxy somewhere far away. Now, the scale of space-time in that galaxy was lower than the scale of space-time now, because the universe is expanding with an exponential expansion constant of 13.8 billion years. So the universal scale doubling time is 9.56 billion years. So my theory predicts that the deep space redshifts will get exponentially deeper as you look further out, and there is no dark energy. And the cosmic microwave background is not coming from the Big Bang, that's coming from a big event. But it's when Hello? Hello?
Okay. Okay. I'm so sorry for the interruption. Please do continue. I'm so sorry.
Yeah, okay. No problem, Jessica. The cosmic microwave background is not coming from the Big Bang. There may have been a Big Bang, but it was a lot further back in time than that. I put the universe at about at least 10 to the 80 years old. But the only interesting things that have happened in it have happened in the last few billion years, of course. So, and what you've been taught so far by these cosmologists who have absolutely nothing but contempt for is that the whole universe is only 3 or 2.8 or 3 times older than the Earth, and that's nonsense. The universe is a lot older than that. It might be infinitely old, or it might not be infinitely old, but it's a lot older than 3 times older than the Earth. I mean, you know, talk about star generations. I mean, you know, how many do you need before you get the sophisticated cocktails which could produce a place like Earth? I mean, it takes hundreds of generations, not just, you know, how many generations could you have in 3 Earth ages? It's nonsense. And that's all sorted out by Gauss-Newton quantum relativity. But I don't normally major on the cosmological aspects of GNQR because, you know, it's a bit of a shock for people. And really the big benefits from GNQR is quantum physicists understanding what they're talking about. Because if you don't know what space and time are, if you know what space is, but you don't know what time is, then you're working with your hands tied behind your back. And time is really simple. It's the imaginary historic depth. And so I'd like to just leave it there. I don't know if anybody's got any questions. That's it. Thank you.
Thank you for your talk, Dr. Ben. So yeah, do we have any of you have anything to ask for? Any questions or any doubts or anything related to anything like you would like to ask him out?
One thing I'd like to say, Jessica, is that I do not have a PhD. I mean, I basically explained that in my talk, that I basically didn't get an education. So if you think that I spent years slogging away to get a PhD from people who don't know what they're talking about, no, I didn't. So I've just missed. Like Einstein.
Oh.
Albert Einstein was Mr. Einstein, wasn't he? Oh, I'd be quite happy with that.
Yeah. Okay, so anyway, thank you for your time and your patience, and thanks a lot for your presentation, then.
Okay.
There are no questions.
It's a pleasure. But they either didn't understand a word I said, or they think I'm mad, or they're just gobsmacked, and I don't even know. Nobody gets in touch. Nobody gets in touch with me and asks me questions about my website either. I've had, I don't know, 7,000 people have visited my website. Never once has anybody sort of said, "Can you explain this?" or "I think you're wrong here," which I'd love to have, you know, but I don't get it.
So thank you. Thanks a lot for your time.
You're welcome.